the first 3 seconds, this aircraft wasn't built to fight, but it was built to control the skies. The sound of supersonic wind, the clanging of metal as the wings spread, and a massive silhouette moving through the clouds. This isn't an ordinary fighter jet. This is a symbol of an era in aviation history. Its name is F-14 Tomcat. The F-14 wasn't just a fighter jet. It was the answer to the most difficult question of the Cold War era. The question, if the enemy is coming from far away, coming fast, and with a large number of weapons, how can we stop them before they reach land? In the late 1960s, the world was divided into two power blocks. On one side was the United States, on the other was the Soviet Union. The battle didn't begin on the battlefield. It began with radar. It began with detection. It began who saw first, who fired first. The U.S. Navy faced a new type of threat: long-range bombers, anti-ship missiles, and attacks from beyond the horizon. Aircraft carriers, the heart of naval power, became the #1 target. And so the F-14 Tomcat was born. Not for one-on-one duels, but to serve as a frontline guardian. What sets the F-14 apart from other aircraft of its time is its ahead-of-the-art concept. It wasn't the fastest, it wasn't the smallest, but it was the first to see. The heart of the F-14 was its massive radar system, the AN-AWG-9, a radar capable of detecting targets over 100 miles away, tracking dozens of targets simultaneously, and selecting multiple targets to attack at the same time. In an era when computers were the size of refrigerators, the F-14 carried the most sophisticated artificial intelligence in the aviation world at that time. It didn't just see, it analyzed, predicted, and prioritized threats. And to support this mission, the F-14 didn't fly alone. It had a crew of 2, a front pilot and a rear radar control officer, known as RIO. This is where the F-14 is profoundly different. It's the collaboration between humans and technology. Decision-making isn't solely dependent on one person, but on the coordination of information, understanding, and experience. Another unique feature that made the F-14 a legend is its automatically variable wings. Wings that can extend at low speeds and fold inward towards the fuselage at high speeds. This concept isn't aesthetically pleasing, but it's engineering that addresses reality. The F-14 had to take off and land from ship decks. It had to fly steadily at low speeds, and at the same time, it had to accelerate at high speeds for interception missions. The variable wings made the F-14 both a hunter and a watchtower. When it officially entered service in 1974, the F-14 immediately became a cornerstone of the U.S. Navy. It was deployed on aircraft carriers around the world, from the Pacific Ocean to the Mediterranean Sea, from the Indian Ocean to the Persian Gulf. The F-14 wasn't primarily designed for ground attack, but reality doesn't stand still. Over time, the F-14 was upgraded. New systems were installed. Its capabilities for attacking ground targets, reconnaissance imaging, and guided missile targeting were enhanced. It's not the most flexible aircraft, but it's an aircraft that learns with the times. Beyond the United States, there's another country where the F-14 played a crucial role: Iran. Before the Islamic Revolution, Iran is one of the United States' key allies and the only country outside the U.S. to deploy the F-14. That decision gave the F-14 another side of its story, a side of operation in different environments with limited resources, but with the high adaptability of humans. Even today, the F-14 is still talked about, not because it's still in service, but because it represents an era where engineering was pushed to its limits, an era where technology was created to prevent war, by making the enemy aware that approaching has a price to pay. And this is just the beginning of the whole story. In the next installment, we will delve deeper into its structure, its electronic systems, the operation of its radar.
If an aircraft is a body, what sets the F-14 Tomcat apart from all other aircraft of its time is its brain. Before the F-14 was built, most fighter jets could only see what was directly in front of them, had limited target detection capabilities, and relied heavily on guidance from ground or warship control. But the F-14 was designed to perform tasks that no one had ever done before. It had to see threats from a distance, distinguish between primary and secondary targets, and make decisions within seconds. The heart of all this is the AN/AWG-9 radar. This radar isn't just powerful, it's intelligent. It can detect targets over 160 kilometers away, track more than 20 targets simultaneously, and select up to 6 targets at the same time. In an era when computers still used vacuum tubes and memory was extremely limited, the AWG-9 acted like a flying command center. It scanned the sky, analyzed the speed, direction, altitude, and movement behavior of every object it detected. Not everything that flies would be perceived as a threat. The F-14's radar is designed to think for humans. It calculates which targets are approaching, which targets are fleeing, and which targets are likely to attack the aircraft carrier. All this information isn't expressed in complex numbers, but it's transformed into images, symbols, and a language that humans understand in a fraction of a second. This is why the F-14 needs 2 crew members. The front pilot focuses on the flight, speed, direction, and the surrounding situation. The RIO in the backseat is the tactical brain. He reads the radar, analyzes the data, selects targets, and decides what to do next. The relationship between the pilot and the RIO isn't a commander-discipline relationship, but a team that must trust each other completely. Because in a real situation, 1 second can mean life or death. The F-14 doesn't just receive information from its own radar, but it can also receive information from the aircraft carrier, from early warning aircraft, and from other units in the fleet. This is a concept called network warfare. Before this term became commonplace in the digital age, the F-14 acted as a central node in the entire defense system. It didn't always need to fire. Sometimes just having sight was enough to change the enemy's plan. Another key technology is the radar weapon link. The F-14 is designed to work with long-range missiles, which require continuous target information. The radar doesn't stop working after a weapon launch. It continues to track, calculate, and update information for the guidance system until the weapon reaches its target. All of this must operate in harsh environments, vibration, fluctuating temperatures, and unpredictable weather. The F-14's electronics are therefore designed to be durable, maintainable, and reusable on aircraft carriers at sea for months at a time. But advancement often comes with complexity. The F-14 is a highly maintenance-intensive aircraft. Numerous systems, kilometers of cables, and components that must work together with precision. This is the price of technological leadership. And this is why the F-14 has become so beloved and the challenge for every technician. However, when everything works together, the F-14 becomes an incredibly amazing machine. It's not just an airplane, but a flying combat control center. And when we look back, we see that many concepts used in modern aircraft have their roots in the F-14. Centralized data processing, the collaboration between humans and automation, and data-driven warfare. All of this began in the sky, with an aircraft that was built to see first, think first, and decide first. In the next installment, we'll delve deeper to see how the engineering of variable wings defies the laws of physics and why it's both a strength and the point that makes the F-14 an unparalleled legend. Ready? Let me know. Part 3 will take you on a super nerd-level wing dissection of the F-14.
If radar is the brain, then the F-14 Tomcat's wings are proof of how much humans can manipulate physics
to meet the demands of warfare. The F-14 is a variable sweep wing fighter with wings that can be extended or retracted during flight. This concept didn't arise from aesthetics, but from a very real problem. Slow-flying aircraft require wide wings to create high lift and safely take off and land from aircraft carrier decks. But fast-flying aircraft require narrow wings to reduce air resistance and maintain stability at supersonic speeds. In the past, designers had to choose one or the other, but the F-14 chose to have both. During takeoff and landing, the F-14's wings spread wide, increasing air contact area, reducing gliding speed, and making landing on a carrier deck, short and dangerous, controllable. When entering high-speed flight, the wings gradually fold back, changing the aircraft's shape to make it sleeker, to reduce drag, and to increase stability at very high speeds. All of this is not controlled manually in a simple way, but by an automated system that calculates based on speed, air angle of attack, aircraft weight, and current flight conditions. The pilot can select a mode or let the system manage everything itself. This is where the challenges begin, because movable wings mean an extremely complex structure. Large pivot points, hydraulic mechanisms, sensors, and safety systems that must work simultaneously without any room for error. If the wings move even slightly unevenly, the entire aircraft could instantly lose balance. Therefore, F-14 engineers designed a system with redundant backup systems. Every movement is rechecked, and there are immediate shutdown measures in case of malfunction. In addition to the main wings, the F-14 also has other control surfaces that work together in a complex manner, including the horizontal stabilizer, twin vertical stabilizers, and forward lift control plates. All of this is designed to keep the large aircraft groovy, responding quickly, and precisely controllable, even in high pressure and stressful situations. What's interesting is that despite the F-14's size and weight, many pilots describe it as feeling stable. It's not a jerky aircraft, but a steady one, like a platform designed to think and plan. Variable wings also allow the F-14 to perform a variety of missions. It can fly slowly for escort, fast for interception, and stay airborne for extended periods without losing stability. But like all cutting-edge technology, complexity also comes with a burden. Variable wing systems require extensive inspection and maintenance. Mechanics must check every pivot point, every hydraulic pressure, and every hidden mechanism within the fuselage. This is why in later years, many newer aircraft chose fixed-wing designs, combined with more advanced materials and aerodynamics. Even so, no one can deny that the F-14 is the pinnacle of the variable wing concept, and one of the few aircraft that has proven this concept practicable on the battlefield. When you watch an F-14 fly by, you don't just see metal and engines, you see a negotiation between humanity and the laws of nature, engineering decisions, choosing the challenge in exchange for unparalleled capability. And all of this is only part of the story. In the next installment, we will explore another side of the F-14, a side that is rarely talked about, but equally important. The side of actual deployment, its role on aircraft carriers, the lives of the crew, and why the F-14 is not just an aircraft, but a symbol of an era in military aviation history.
If the sky is the battlefield, then the aircraft deck is the examination ground with no room for retakes. The F-14 Tomcat wasn't designed to excel only in the air. It was designed to operate on a constantly moving steel ship in the midst of waves, salt spray, and an area where even the slightest mistake is unacceptable. An aircraft carrier is not an airfield. It's shorter, narrower, and constantly moving. As an aircraft is preparing to land, the deck is rocking, the sea breeze changes direction, and the pilot has only seconds to decide whether to land or pull back up. The F-14 was designed specifically to deal with this reality. Fully extended variable wings increase lift at low speeds, allowing the large aircraft to glide stably, even with a full load of fuel and equipment. The nose and main landing gear are specially reinforced to absorb the impact of a violent landing, which is completely different from landing on a normal runway. But the heart of ship landing isn't just the wheels, it's the grab, a large metal hook extending from the rear of the aircraft. Its function is to engage the cable on the deck to stop the aircraft within a few tens of meters. At the moment the hook engages the cable, the pulling force violently jerks the aircraft. The resulting G-force is many times higher than braking on the ground. The F-14's fuselage structure is designed to withstand this force repeatedly without losing strength over the long term. And if it misses, if the hook fails to engage, if the cable breaks, the pilot must immediately push the throttle to full power to retake in an area with very little room for error. This is why the F-14's engines must provide high thrust and be highly responsive, especially at low speeds. In the early days, the TF-30 engine had limitations and responsiveness problems, which became an important lesson leading to improvements in later engine models. But despite these limitations, the F-14 continues to be heavily used because of its capabilities. No other aircraft can easily replace it. On aircraft carriers, the F-14 doesn't just perform takeoffs and landings. It is the vanguard of the fleet. Its primary mission is to protect the fleet from long-range threats. Especially with bombers or guided missiles that might come close to the ship, the F-14 must stay in the air for long periods, circling, monitoring, and being ready to respond immediately. This is why it has a two-person crew. The pilot, responsible for controlling the aircraft, navigating, and making overall tactical decisions. The other position is the Radar and Weapons Systems Operator, or RIO. The RIO is not a helper, but the other half of the aircraft's brain. They must monitor the radar, assess the situation, identify targets, and communicate with the fleet's systems. All of this happens simultaneously in a highly stressful environment. The relationship between the pilot and the RIO is therefore not just about working together, but a trust of the life or death level. On the ship, the F-14 is positioned in a crucial location, both strategically and morale-boosting. It's an iconic aircraft. Its engine sound, its distinctive wing shape, and its powerful takeoff and landing have made it a symbol of the fleet. But at the same time, it's a resource-intensive aircraft in terms of fuel, maintenance, and manpower. On every flight, a large team of technicians works behind the scenes. Every system checked, every line, every lock. The F-14 is not an aircraft that forgives carelessness. It requires discipline, knowledge, and respect for its limits. And this is the reason it is celebrated. Not because it is perfect, but because it reflects an era where humanity accepts complexity in exchange for ultimate control. Some aircraft are not remembered simply because they still fly, but because of what they once protected. The F-14 Tomcat didn't depart silently. It departed with an era where the skies were filled with confrontation between two global powers. As the Cold War began to ease, threats changed. Technology advanced faster than the structures designed decades earlier. The F-14 was still powerful, still formidable, but the world wasn't the same.
the large, advanced radar systems began to be replaced by smaller, smarter, and more interconnected systems. Maintenance, requiring numerous technicians, became a burden in an era where militaries needed agility more than grandeur. And eventually, the F-14 reached an inevitable point: decommissioning. But this isn't the end of the story, because the legend doesn't end simply when the aircraft stops flying. The F-14 left a rich legacy: the concept of variable wings, human radar collaboration, and a crucial lesson that true power never comes from technology alone, but it comes from the people who control it. Looking back, the F-14 was a reflection of American aviation philosophy: large size, high power, wide coverage, and prioritizing remote air control. But the world doesn't have just one concept. On the other side of the world, another camp was developing a different concept, not focusing on size, not focusing on unnecessary complexity, but on agility, aggression, and air superiority in close combat. As the F-14 gradually disappeared from the skies, a new name began to sound, not from aircraft carriers, but from the vast runways of the Eurasian continent. That was the world of Russian fighter jets. A world where design didn't begin with comfort, but with the harshest assumptions. What if the systems failed? What if the signals were jammed? What if it had to be a one-on-one fight? This concept shaped a particular aircraft, an aircraft that doesn't try to be stealthy, but chooses to confront others. An aircraft designed to be controlled as if it were an extension of the body, flipping, rotating, and changing direction in a way that defies the laws of physics. From the era of the F-14 focused on first detection, first shooter, and remote area control, the world is moving to a new era, an era where engagements may occur faster, closer, and more fiercely than before. And that's where one name begins to be mentioned more and more: the Su-35 Flanker E, an aircraft representing a new Russian philosophy: immense engine power, supersonic agility, and a design that embraces the realities of combat rather than the pursuit of theoretical perfection. If the F-14 was the king of fleet escort, the Su-35 is the beast of the skies, ready to engage no matter where the enemy is. From the skies above the ocean, we are moving to the skies above the land. From the United States to Russia, from a decommissioned legend to an aircraft that still roars today. The story of the F-14 doesn't end in silence, but it's leaving us with one question. As technology changes, the threat changes, and the world has changed. Who will dominate the airspace in the next era? The answer is waiting for the next episode with the aircraft called Su-35 Flanker E.